Jai Hind, everyone. I am from Indian Space Team PR department. Today, we discuss about Mars orbit and his moons. Have you ever wondered why Mars, our neighboring red planet, takes longer than Earth to complete one orbit around the Sun? It all comes down to distance and orbital mechanics. Mars is about 143 million miles away from the Sun, almost double the distance of Earth. Because of this greater distance, it takes Mars approximately 687 Earth days to complete one full orbit. Now, let's talk about a day on Mars, or as scientists call it, a sol. A Martian sol is only slightly longer than an Earth day, clocking in at about 24 hours and 39 minutes. This minor difference adds up over time, meaning that a Martian year, the time it takes for Mars to orbit the Sun once, equals about 1.88 Earth years, or 1 year 320 days, and roughly 18 hours. But Mars doesn't just have a longer year, it also has a different axial tilt. Mars tilts at an angle of about 25.19 degrees relative to its orbital plane. This tilt is similar to Earth's, and it's responsible for the changing seasons we experience here on our home planet. Yet on Mars, these seasons are nearly twice as long. Why is that? Well, because Mars takes longer to orbit the Sun, each Martian season, spring, summer, autumn and winter, also last longer. So, while we enjoy spring blossoms or autumn leaves, Mars might still be locked in a long, cold winter or enduring a lengthy, dusty summer. It's fascinating to think about, isn't it? Despite the stark differences between our two planets, some things remain quite similar. The very tilt that causes our earthly seasons also causes Martian seasons. So with its longer orbital period and similar axial tilt, Mars experiences seasons just like Earth, only they last nearly twice as long. Did you know that Mars has a more pronounced orbital eccentricity than any other planet except Mercury? Now, you might be wondering, what is orbital eccentricity? Well, it's a measure that describes how much an orbit deviates from a perfect circle, and Mars, with an eccentricity of about 0.09, has a pretty elliptical orbit. In fact, Mars's orbit wasn't always this eccentric. Rewind the cosmic clock about 1.35 million Earth years, and you'd find Mars in a much more circular orbit with an eccentricity of roughly 0.002. That's even less than Earth's current eccentricity, but just like a pendulum, Mars' eccentricity swings back and forth over a cycle of 96,000 Earth years, making its orbit a dynamic, ever-changing path. Now let's talk about something called opposition. In space terms, opposition is when Mars and the Sun are on directly opposite sides of Earth. This is the best time to see Mars from Earth because it's at its brightest and closest point. Mars comes into opposition every 780 days, or roughly every 2.1 Earth years. But here's where it gets interesting. Due to the eccentricity of its orbit, the distance between Earth and Mars at opposition can vary dramatically, ranging from about 54 to 103 million kilometers. That's a massive difference of 49 million kilometers. So some oppositions bring Mars much closer to us than others, giving astronomers and space enthusiasts a spectacular view of the red planet. But there's a flip side to the coin. When Mars is in conjunction, it's at the opposite side of the Sun from Earth, making it almost impossible to observe. So the eccentricity of Mars's orbit not only influences its distance from the Sun and Earth, but also the opportunities we have to observe it. With its eccentric orbit and regular oppositions, Mars offers a fascinating spectacle for us to observe from Earth. Ever spotted a distinctly red bright spot in the sky and wondered if that's Mars? Well, that's a possibility. Mars is a fascinating celestial body, and when it's in the right position, it can be quite a spectacle in our night sky. Mars's brightness in our night sky, also known as its apparent magnitude, averages around +0.71, but it can vary significantly. This is due to the eccentricity of Mars's orbit, which affects how far it is from Earth at any given time. When Mars is at its closest to Earth, it can shine with a magnitude of around -2.9, making it brighter than the majority of stars. Its minimum brightness is magnitude +1. 86 when the planet is near aphelion, that is, at its farthest from the Sun. The distance between Earth and Mars also influences the planet's apparent color. When Mars is closer, it usually appears distinctly yellow, orange, or red. But when it's further away, it can seem somewhat fainter and less colorful. Now let's talk about a fascinating phenomenon: Mars's retrograde motion. As Earth and Mars orbit the Sun, there are times when Earth, moving faster along its orbit, overtakes Mars. During this period, Mars appears to move backwards in a looping curve with respect to the stars. This is what we call retrograde motion, and it lasts for about 72 days. Mars reaches its peak apparent brightness in the middle of this retrograde period, making it a prime time for viewing the planet. Remember, however, that Mars isn't always visible in our night sky. It only comes into opposition, or its closest approach to Earth, every 2.1 years, but when it does, and especially when this coincides with Mars being at or near perihelion, it can be a truly breathtaking sight. So, depending on its position in its orbit, Mars can be a spectacular sight in our night sky. So the next time you spot that bright red dot, take a moment to appreciate our fascinating neighbor, Mars. What if I told you that Mars, unlike our planet, has not one, but two moons? Yes, you heard it right. The red planet has a couple of celestial companions, Phobos and Deimos, named after the Greek gods of fear and terror, respectively. Fitting companions for the god of war. Let's start with Phobos, the larger of the two. Despite being the bigger sibling, Phobos is still relatively small, measuring about 14 miles in diameter. This moon is closer to its parent planet than any other moon in the solar system, orbiting a mere 3,700 miles above the Martian surface. To put that into perspective, that's closer than some of our satellites are to Earth. Now onto Deimos, the smaller moon of Mars. With a diameter of just about 7.5 miles, Deimos is about half the size of Phobos. Despite its small size, Deimos orbits Mars at a much greater distance than its larger sibling, averaging a distance of about 14,000 miles from the Martian surface. One of the most intriguing aspects of these two moons is the mystery that surrounds their origin. Scientists are still not sure where they came from. Some theories suggest that they could be asteroids captured by Mars' gravitational pull. Others propose that they may be remnants of a larger moon that was shattered by a massive impact. The moons of Mars, though small, have a lot to offer in terms of scientific exploration. In fact, NASA is considering sending a mission to Phobos or Deimos, which could act as a stepping stone for future manned missions to Mars. Despite their small size and close proximity, Phobos and Deimos are intriguing moons that add to the mystery of Mars. As we continue to explore the red planet and its celestial companions, who knows what secrets we might uncover? As we've seen, Mars is a planet full of surprises. Its dance around the sun is a mesmerizing choreography of celestial physics. The red planet takes 687 Earth days to complete a single orbit, a Martian year, making its seasons nearly twice as long as our own. The length of a day on Mars, known as a sol, is only a smidgen longer than an Earth day, clocking in at 24 hours 39 minutes and a bit over 35 seconds. The similarity in axial tilt between Mars and Earth results in analogous seasonal changes, creating a familiar rhythm on an alien world. Yet Mars also exhibits a unique flair. It has a pronounced orbital eccentricity, only outdone in our solar system by Mercury. This elliptical path has varied over millions of years, reflecting a dynamic and evolving planet. Mars's eccentricity cycle is 96,000 Earth years, a stark contrast to Earth's 100,000-year cycle. These factors contribute to the intriguing phenomenon of Mars oppositions, where Earth and Mars align in their orbits, bringing them closer together every 780 days on average. Mars also boasts two petite yet intriguing moons, Phobos and Deimos. These celestial bodies, with their close orbits and irregular shapes, add to the mystery and allure of the red planet. Despite their small size, they hold significant interest for scientists and space enthusiasts alike, as their origins and compositions could provide valuable clues about the history and makeup of our solar system. These fascinating aspects of Mars's orbital motion and its moons make it a captivating object of study. Each discovery we make about Mars, from its axial tilt to its unique moons, enriches our understanding of the cosmos. It's not just about understanding Mars itself, but about gaining insights into the workings of our vast and wondrous universe. With its unique orbital characteristics and intriguing moons, Mars continues to captivate our curiosity, pushing us to explore and understand our celestial neighborhood. Please share this video.